Yeah, just highlight some of the easy, quick ways. Most of them are quick ways. Some are quicker than others. Just some easy, quick ways to know whether or not a number is divisible by another number. Probably the easiest one of all, well, one of the easiest ones, is of course divisible by 2. It's easy to tell if a number is divisible by 2, isn't it? If it's even, okay, if it ends in 0 or 2 or 4 or 6 or 8. If it ends in one of those, it's divisible by 2. But there's some others. And that's what I wanted to show you here. Let me give you this little handout. For divisibility tests. Start off with the other easy ones, the top two on this sheet. You'll see why I'm grouping them like this. Five and 10 are also easy tests, aren't they? How can you tell a number is divisible by 5 if what? Yeah, if you go through multiples of 5, 5, 10, 15, 20, 25, 30, they always end in what? 5 or 0, yeah. Number is divisible by 5 if it ends with 5 or 0. 0 or 5. And then 10 is even easier because always, if it's divisible by 10, it ends with a 0, right? 10, 20, 30, 40, 60. Yeah. So those are two easy ones. All right, we've already done the next one. A number is divisible by 2. Just by looking at the last digit, right? If it ends with 0, 2, 4, 6, or 8. Now, I group the next two with that. Number is divisible by 4. Turns out, a number is divisible by 4 if you look at the last two digits. A number is divisible by 4 if the last two digits form a number divisible by 4. For 2, you just look at the last digit. For 4, you look at the last two. So it doesn't matter if your number is 9,461,240. Let's make it 16. Because 16 is on the end, that's the last two digits, this number is divisible by 4. It just matters those last two. Did you know that? May not have known that. Yeah. For 4, you just have to look at the last two. Not the last one, just the last two. Or move up to the last two. All right, so therefore, does it really matter what these are? No. It just matters the last two. Now, I group that with the 8. A number is divisible by 8 if the last three digits form a number divisible by 8. For 8, you look at the last three. So if I had 10,631,000, and then the last three were, let's make it 24. No. 824, yeah. No. Let's don't do that. Let's make it 160. Yeah, that'd be good. For 8, you just look at the last three. 160, is that divisible by 8? goes evenly 20 times, doesn't it? Does the last 2 divisible by 8? No. The last 1 divisible by 8? No. It's the last 3. You have to look at the last 3. This whole number is divisible by 8 just because that is. So these other numbers, whatever they are, change them up, put more digits out here. It's always going to be divisible by 8 because those last 3 are. Now, pointing that out, what if this was 18 here? Would this be divisible by 4? I didn't mention it, but if this was 18, would it be divisible by 4? No, because 18 is not divisible by 4. Just change it up a little bit, and it makes it not. So it works in reverse there too. Okay. So I grouped these 3 together because notice the 2 you look at the last digit, the 4 you look at the last 2, and then 8 you look at the last 3. So those which are all powers of 2 all work similarly. Just look at one more extra digit for the higher numbers there. Okay? All right. Now I've got 3 and 9 grouped there together. Numbers divisible by 3. Does anybody know that one? A number is divisible by 3 if what? What's the test? Well, it's not quite as nice as the 2 or 5 or 0. It turns out you look at the sum of it. Number is divisible by 3 if the sum of the digits, all the digits, is divisible by 3. You add the digits. For example, 174. Probably not a known multiple of 3, but right from here I can tell that one is divisible by 3, because what do you get if you add the digits? 12. It's divisible by 3. Add the digits. It's a quick check to tell, especially on smaller numbers, but it works for larger numbers too. If it's add the digits and they're divisible by 3, then the whole number is divisible by 3. It goes evenly, divide by 3. Doesn't matter how many there are. Let's try 4,267,527. Is that divisible by 3? Well, if you add up the digits, 4,267,527. What does that give you? 12, 19, and 14 is 33. All of them. Not just the last 3. That's right. It's all of them. All of them. Sum of all the digits. Well, I grouped that with 9 because it's the same thing with 9. A number is divisible by 9 if the sum of its digits is divisible by 9. So it's nice because it goes along with 3. Add them up. So what about either one of these I've got here? Is this divisible by 9? No, it's not. You add them up, you get 12. That's not divisible by 9. This one divisible by 9? No, because you add them up, you get 33. That's not divisible by 9. So the sum of the digits has to be 36 or 72 or something that's divisible by 9. So neither one of those would be. What if I did, let's make it 189. That's 18. That's divisible by 9, isn't it? So this 189 is divisible by 9. So it's a nice little check, especially on smaller numbers. Now when you get bigger, you have to add them up, and just like we did with that one. But That larger one. But it works. Okay? All right. Now, I grouped 6 and 12 there at the bottom because actually those two are combinations of some tests. A number is divisible by 6 if it is divisible by 2 and 3. So it's a combination. If you use the test, it's the combination of the 2 test and the 3 test. If it's even, right, it's divisible by 2. And if the sum of the digits is divisible by 3, then it's divisible by 6. You work off of those 2 tests. So it's a combination. And it has to be even, but it also has to be divisible by 3, so the sum of the digits also has to be divisible by 3 by the test. Okay? Now, why would you use 2 and 3? Well, 6 is 2 times 3, right? So that's why it works for 6. Now, the other one, a number is divisible by 12. Well, let me mention this. Now, you can't always just combine the tests. Like for 8, could I use the test for 2 and 4? And the answer is no. If a number is divisible by 2 and by 4, it doesn't mean it's necessarily divisible by 8. Proof of that, 20. Is that divisible by 2? Yes. Is it divisible by 4? Yeah. Is it divisible by 8? Nope. So it's divisible by 2 and 4, so I couldn't say, yeah, it's divisible by 2 and 4, so therefore it's divisible by 8. No, you can't say that. The reason 2 and 3 work, well, it has to do with common factors. 2 and 3 don't have a common factor other than 1. 2 and 4 have a common factor of 2. So you can combine the tests so long as they don't have a common factor other than 1. Having said that, then moving on to 12 here, what would be the 2 tests I could combine to make 12? Could I do 2 and 6? No. 2 and 6 have a common factor. What could I do, though? 12, it's divisible by 12 if it is divisible by 3 and by 4. So in other words, the sum of the digits is divisible by 3 and the last 2 digits is divisible by 4. Okay? So anyway, that's divisibility tests. And yeah, the last 2 had to be divisible by 4. And the sum of the digits is divisible by 3. So for example, let's do 9,132. That's divisible by 12 because 32 divisible by 4, right? And then 9 plus 1 plus 3 plus 2 is 15, divisible by 3. So that's divisible by 12, you see. So there are a couple of problems where you will, just straightforward, is this divisible by, using the divisibility test. And yes, you will need to know these for the test, when the test rolls around anyway. You will need to know those, but there are some straightforwards. Let me show you the problems that I like on these, though.
That is no in that, right?
What?
That is not divisible by 3 and 4. Did I lose that? Yeah.
It's divisible by 3.
Yes.
Because it's 15.
Yes.
32 is divisible by 4, isn't it? 32, the number, is divisible by, goes into 8 times.
So we add them all up to find 3, and then we use the last 2.
Oh, yeah. For 4, yeah, you don't add them up. For 4, you just look at 32.
Okay, but 3 we have to add up.
3, you add them up.
Ooh, I hope that is.
Yeah, a little confused. That was divisible by, yes, it is divisible by 12. All right, but here's, let me give you one more little problem here. Okay. Yeah, it would also be divisible by 6, wouldn't it? Sure would, because it's even and it's divisible by 3. Okay. All right, so here's what I want us to do. Last one. Construct a 12-digit number that is divisible by 2, 5, and 9. And the hint is use the divisibility test. So know those tests to do these problems, all right? So here's the way I break it down. Got 12 digits. Oh, the other thing on these to kind of rule out the obvious ones, use, let's just say, use no digit more than 3 times. There's a little bit of restriction. So that rules out 900 trillion or whatever, where you just do 9 and then with all the rest zeros. That rules that one out, okay. The easy one. Now if I use the test, what is the test for 2? It has to end in a number 0, 2, 4, 6, or 8. What's the test for 5? Has to end in a 0 or a 5. And the test for 9, all the digits add up to be something divisible by 9. That's the easy way to go here. Now, since these two focus on the last digit, let's think about that first. To make it divisible by 2, it has to end in 0, 2, 4, 6, or 8. Divisible by 5, it has to end in 0 or 5. So what does that last digit have to be? Then the last digit have to be 0? Why can't it be 5? Well, if it's 5, it's not divisible by 2, is it? So the last digit has to be 0. Now, the rest of them are fair game. They're pretty open. So I've got these two taken care of. It's just now the 9 one. And so to make it divisible by 9, the sum has to be divisible by 9. Well, here's an easy way to do it. If you kind of group these in 3s and make those groups divisible by 9 each, it goes a little faster maybe. You don't have to do it this way, but let's say I make this 450. 4 plus 5 plus 0 is 9. So that gives me 9. Let's make this one another 9. Let's make it, how about, 318. No, not 318, 315. Yeah. 3 plus 1 plus 5, that gives me 9. Again. Let's make these last two 18s maybe. So if I make this 18, I could do, how about a 6 and 7 and 9. No, 5. That's 18, isn't it? And then let's make this again 18 with a 1, 8, 9. That's 18 again. So if I add those, (18, 18, 9, and 9 is 54, which is divisible by 9, isn't it? Wouldn't the sum of the digits there be 54 by our calculation? Divisible by 9, isn't it? There you go. 189 trillion, 675 billion, 315,450. Divisible by 2 and 5 and 9.
There be more than one answer.
Yes, there is definitely more than one answer here.
As long as we get one of them. Okay.
As long as you get one of them, that's right. But that's where the tests come in. As long as it's, you know, divisible. I could change up, you know, I could change this up to be 279, couldn't I? That'd be another one. All sorts of different combinations, sure.
So that 54 has to be divisible by 2, 5, and 9.
No,
No?
just the 54 just has to be divisible by 9.
Just by 9.
Yeah, just
So
by
the
9.
answer is just by 9.
Yeah. For the sum of the digits, just divisible by 9, because that's the test for 9. The 2 and the 5 have their own test. The 2, if it ends in a 0, 2, 4, 6, or 8, which it does end in 0. The 5 is it ends in 0 or 5. That's all for those two.
So that 9 could say and 8, and we know it needs to be divisible by 8.
Yeah, if we.
That wording is and.
That's right. Depends on which numbers you're given there. Okay. All right.